Automate everything with Python. Have you ever felt bogged down by those tedious, repetitive tasks that eat up all your time? We've all been there, haven't we? The good news is that there is Python automation. Imagine turning those time-consuming tasks into something that's done at the press of a button. Automation is the major driver of our modern economy. Automation can make you more productive than ever while using fewer resources. And automating processes doesn't have to be hard if you're using the right tools. This is where Python comes in. It's the fastest-growing programming language, with new packages being developed and added every day. Python is also an easy-to-learn programming language that you can use to build your automations. I use programming languages like Python to help businesses and individuals solve problems and save time. In this video, I'll introduce you to some of the interesting ways Python can automate computer operations. You'll dive into automating file manipulation, input validation, error handling, web scraping data, website interactions, and more. By the end of this video, you'll understand the many ways Python can automate tasks and feel confident constructing these automations yourself. So if you're excited about compiling your own robots, let's go. Check out the course prerequisites. This video is for people who know the basics of Python and want to learn how to automate tasks with their code. To succeed with this video, you need to have an understanding of Python logic and syntax. This includes code comments, data types, variables, indexing, functions, operators, conditional statements, and iterative statements. It's also good to have some basic understanding of file and directory paths and command line syntax. Read files with Python. Automating file manipulation with Python is a valuable skill whether you're a data scientist or just trying to optimize your workload. In this section, you'll discover how to use automation with Visual Studio Code to open, read, and close files with Python, and how you can iterate through a file and process the data within. Go ahead and get a sample text file. This file contains some data about people who've recently taken their behind-the-wheel drive test. Each row has the first name of the person, their age, and whether they passed or failed their test. Now let's say the goal is to read input file, TSDS, and print out its contents. Start with the new Python file. Now call the open function and pass in the fill name, including the file type as a string. And you want to pass in the string R for read as a second argument. Next, print out the contents of the file. To do this, call the print function and then input file.read. Lastly, call the close function of the file. This is to make sure the file is closed properly after it's been read. This is a best practice to prevent unintended file changes. Now save this program. You can give it the name readfiles.py. To run the program and test it out with Visual Studio Code, go to Terminal, New Terminal, and then run the following command. Python 3 space readfiles.py. There you go. Here you can see the contents of the text file that you just read in. What if I don't want to print the entire file? Instead, I want to print just the data that represents people who passed the behind-the-wheel drive test. For this, you need to iteratively check each line in the file, determine whether the person passed the drive test, and only if that's true print out that line. Write a for loop that iterates through each line of the file. Inside the loop, split the line using the .split function, which defaults to splitting on whites pass. When reviewing the structure of the input file .txt, you'll notice that each line consists of a name, a whites pass, a number that represents age, a whites pass, and a letter that represents whether the person passed the test or not. The letter is P if they passed and F if they failed. Once you split on white's pass, you're left with a list of 3 elements. Given that indexing starts from 0 in Python, the P or F letter is located at index 2, so I'll write an if statement that checks whether the element at index 2 is equal to the string P. If that condition is true, I'll print out that line. Now save your changes and run the program. There you go. These are the lines of the text file that contain P. Now that you've learned how to read and iterate through files with Python, go ahead and try it out for yourself with another text file. Write files with Python. File manipulation automation can really be a game changer. With this, your scripts are unchained and can access external files anywhere, and your datasets now persist even after the program has finished running. In this section, you'll explore how to use automation to write files in Python based on specific conditions and verify that the files were created properly. Open Write Files starter code.py file. This contains some starter code with comments that guide you through the parts you'll fill in yourself as you follow along. The first line of code opens input file.txt with the intention of reading it. This input file contains some data about people who've recently taken their behind-the-wheel drive test. Each row has the first name of the person, their age, and whether they passed or failed their test. The letter P indicates passing the test, and the letter FF indicates failing the test. Your goal is to write all of the lines that pertain to people who passed the test into a new file called passfile.txt, and all of the lines that pertain to people who failed the test into a new file called failfile.txt. So call the open function to create a file called passfile.txt that the program will write to. Pass in the string W as a second argument to indicate that you want to write into the file. Next, call the open function to create another file called failfile.txt that the program will write to. Then comes the for loop. The for loop should iterate through the lines in input file and check if each line has P at the end. If so, you write that line into pass file. Otherwise, you write that line into fail file. After the for loop, the input file gets closed. Now add a line to close pass file and another line to close fail file. Now save your changes. To run the program and test it out, run the following command. Python 3 space write files starter code.py. Confirm that the new files were created successfully. First, locate passfile.txt. Open it up and check that it only contains lines with P at the end. Then locate failfile.txt. Open it up and check that it only contains lines with FF at the end. And there you go. The program worked. Now that you've learned how to write files with Python, you can practice creating and writing to new text files using Python automation on your own. Use Python's command line interface. Python is magic, and the command line interface, or CLI, is your magic wand. With this, you can enter text commands to configure, navigate, or run programs on any server or computer system. In this section, you'll discover how to use the command line interface with Python and make that magic happen. Here's a Visual Studio Code window with a blank Python file on the top and a terminal at the bottom. In the Python file, write a simple print statement. I'll do print hello world. Go ahead and save this file as example.py. To run this file, use the following command in terminal. Python3 example.py. And it works. Next, you're going to create a new Python file called practice.py that refers to the previous file. To automate terminal commands with Python, you'll be using the subpraces library. Subpraces is a library that connects Python with the command line interface. The subpraces library contains many functions, but the one you'll be working with in this case is the check call function. The perk of the check call function is it runs an executable in terminal and waits until the process has finished before continuing the script. Let's put this into action. First, I'll import the subprases library. Next, I'll create a for loop that iterates over a range of 5 and gives the example.py file a try in each iteration. Inside the loop, I'll call subpraces.checkCall, passing in a list with Python3 as the first element and example.py as a second element. This will tell the computer exactly what to do in the command line, as each element in the list represents an argument in the terminal command. Now save your changes. To test this out, run the following command in terminal. Python3 practice.py. The program works. It prints out hello world 5 times. Great. And with that, you now know the basics of executing terminal commands in Python. Organize directories with Python. Ready to get your files in tip-top shape? Python can be so handy to sort and streamline your files and directories. In this section, you'll explore how to use Python to organize file directories. Your goal is to create a program that generates new directories for each file type and organizes a sample directory. Next, open the Organize Me folder in Visual Studio Code and go to organizestartercode.py. At the top, the first import statement imports the OS library, which contains functions for interacting with your operating system. Then the second import statement imports the path function from the pathlib library. Next, a dictionary named subdecretor cfees is defined. It maps 4 basic categories: documents, audios, videos, and images, 2 lists of specific file types. Then a function named organizeDirectory is defined. This takes in a value that represents a file suffix it can encounter and returns a category based on the file suffix. This function requires a for loop to go through the items in the dictionary. If the function encounters a suffix that doesn't correspond to the 4 categories defined here, it returns a 5th category, miss, to represent miscellaneous. To test this function out, call it on .pdff as an example, and print out the result. Make sure to save your changes, and then run the program through the terminal. As expected, you get documents as the output in terminal. The final function that's defined is organize directory. This function requires a for loop to iterate through each file in the current working directory. If the directory that the file maps to already exists, it skips over the rest of the function body. Otherwise, a file path is created. From that, the file type is extracted. Next, the pick directory function that you defined previously is called to assign the correct directory to the current file. Then a directory path is created. If the directory path doesn't already exist, a new directory is created. Finally, the file path is updated to include the new directory path. Now you can call the organize directory function. Time to test out the program. Before running the code, make sure your program is saved within the directory that needs organizing. In this case, the directory is organize me. In the terminal, first run the program, then run the command ls to check whether the new subdecorator CFs were created. There you go. You should find 5 new subdecorator CFs: audios, documents, images, miss, and videos. Go ahead and navigate to each of these subdecorator CFs and check them out. All organized. And with that, you now have the power to organize directories with Python. Parse data with Python. Ever found yourself staring at a dense file of raw data, wondering how to extract the nuggets of information you need? In this section, you'll unlock the power of parsing in Python, a skill that will help you decipher raw data and extract precisely what you're looking for. I'll be showing you how to parse data with Python. You'll gain techniques for parsing different types of data sources, including TXT, CSV, JSON, and XAML files in Python. From the example files folder, there are 8 files that will be referenced in this demonstration. To follow along, open up groceries.txt, groceries.csv, groceries.json, groceries.xml, parse data part 1.py, parse data part 2.py, parse data part 3.py, and parse data part 4.py. Let's start with parsing data from groceries.txt, which contains grocery data with comma separating one item from the next. The first step is defining the file path, which is groceries.txt in this case. Next is a with statement to open the file. Inside the with statement, file.read is used to read the data from the file, which is then saved in a variable named data. This will be a string that contains the grocery information. Afterwards, the data is printed out. To parse this data, the .split function is called. This splits the string of grocery data into a list, so each grocery item can be accessed individually. I've made the function split every time it encounters a comma followed by a whitespace. Then I've printed out the parse data. As an example, if I wanted to access the grocery item at index 2, I could index the list and print it out. Go ahead and run the program to check out the result. As the output shows, the item at index 2 is carrots. Let's move on to parsing data from groceries.csv, which is a CSV file with two columns, grocery item and quantity. At the top, the CSV library has been imported. Next, the file path is defined, which is groceries.csv. Then there's a with statement to open the CSV file. Inside the with statement, the CSV.reader function is called to read the data from the file. To separate the data from the headers, the next function is called. Finally, there's a for loop that iterates through each row of the remaining data. In the loop, the int function is called to convert the data type of the quantity value from string to integer. Then the row gets printed out. Go ahead and run this program. As you can see, each row of the CSV file has been printed out. Now it's time to parse data from groceries.json, which is a JSON file that maps grocery items to quantities. The first step is importing the JSON library, followed by defining the file path. Next is a with statement to open the JSON file. Inside the with statement, file.read is called to read the data. To parse the data with JSON schema, json.loads is called and the result is saved in a variable named parse data. To test out if this worked, I've printed out the quantity associated with the apples grocery item. Go ahead and run the program now. It worked. Apples quantity 2 has been printed out. Lastly, parse groceries.xml, which is an XML file that represents a grocery list. The elements of this XML file represent grocery items. Each grocery item has a name and a price. The first line of code imports the element tree class from the xml.eTree.elementTree module. This class represents the XML data as a tree structure, where each node is an XML element. Then the file path is defined. Next, the .parse function is called to parse the tree. Then tree.getRoot is called to get the root of the tree. Finally, there's a for loop that iterates through each grocery item from the root. In the loop, the name is extracted by calling item.find passing a name as a string followed by .text. The same thing is done for price. At the end, name and price are printed out. Go ahead and run the program. It worked. The names and prices of all the grocery items have been printed out. Now, let's say you want to identify the grocery items that have prices higher than 6. To do this, create a variable named items over 6 that starts off as an empty list. Inside the existing for loop, add an if statement that checks if the price is greater than 6. If so, append the name to the list. In the if condition, you'll need to call the float function to convert the price to a decimal before comparing it with 6. This is because in XML files, all values are represented as strings, so price is a string and needs to be converted to a number. At the end, add a print statement so you can display the final list. Save the changes and run the program. There you go. The name and price of each grocery item from the XML file has been printed out, and the last part of the output tells you that avocados, coffee, almonds, avocado oil, truffle oil, and saffron all have prices over 6. And with that, you now have the power to parse data with Python. Try implementing these parsing techniques on other TXT, CSV, JSON, and XML files of your own.